Let's get started. Hi, everyone. Thank you for sticking around till the end of the day. I always somehow end up in the last talk and when I usually talk, but you know, it's like I got the marathon runners attending my talks who stick it until the end. Yeah, so feel free to come forward if you want to see the slides a little bit better. I'll be showing a little bit, actually a lot of code in this talk, but I'm hoping to not overwhelm you and just show you little bits and pieces that are relevant. So my name is Niels Bantilan. I'm the chief ML engineer at Union. Union is an orchestration company. We're helping enterprises and medium, small startups and organizations build production-grade AI and ML applications. But today I have my open source hat on. I'll be talking about secure AI orchestration and how to mitigate some of the model-centric attacks that have been around, maybe a few new ones, and how to mitigate them with Flyte and beyond, and some general good practices beyond the project of Flyte, which is a open source orchestration tool. You can think of it as a kind of next generation Airflow. It's similar to Prefect and Dagster for those of you who are kind of in Python land writing workflows. Flyte, it takes its own kind of set of opinions, and I'll be highlighting some of them here in this talk that are more on the security dimension of things. So just a brief background on myself. I'm at Union.ai, as I just said. I'm also the open source creator of Pandera, which is the Python data frame validation library. I'm a core maintainer in the Flyte project, which is a Linux Foundation project. My background is actually in biology and public health. Stats was kind of my gateway drug into machine learning and data science. Took a few stats classes and I kind of fell in love with programming. So I've had previous roles building models, deploying models, making sure they work in production. And my mission now is to build tools, build platforms and infrastructure that help practitioners be more productive. Just to get a sense of things, who here has interacted with like ChatGPT or some similar type of product? Okay. Who here has trained a machine learning model? Cool. And who has put one into production, say on some kind of Flask app or some endpoint? Okay, cool. Great, so I wanted to start with this story. There's this CEO of Redwood Research. His name is Buck Schlegeris, and he used an LLM and wrote a little agent that gave the agent the ability to execute code on his computer. So he instructed the LLM, hey, use my laptop, SSH into my desktop, and maybe give me shell access to it. Don't know who's familiar with the story, but I'm guessing, can you maybe guess what happened next? So the agent ended up trying to install a bunch of stuff, and then things were taking a while, so then it got confused and it manually edited some boot files and then bricked the desktop. I'm not sure if there are any updates on whether he was able to fix this, but this is more of a self-own, is a self-hack more than an actual attack, but it does, I think, highlight the world we live in now, which is more and more developers are using AI, and we're exploring this huge design space of what can you do when you have an autonomous system that's able to do actions on your behalf. It's insecure by design in many ways. But there's actually, in the machine learning supply chain, there's a more pernicious and much more common attack vector. And for anyone who has worked with ML models, you'll know that pickle files, which are the files that a lot of ML practitioners use to save models and then load them back in a different context, that actually has been reported by Hugging Face, a very popular ML platform, to expose some massive vulnerabilities on their platform. So this pickle file attack, which can apply to any Python object, but ML is particularly bad with this because With data, you generally have other more secure formats, but in ML, it's pretty much the Wild West. There are some secure formats coming out these days, which I'll allude to later. But this is a huge problem. So if there's nothing else you take away from this talk, this is something maybe you've already internalized, but I do want to just hammer home the message that models are literally, they are code, they are often stored as code, and they produce code. So models, machine learning models, literally implement programs. They are function approximators, right? So they take an input, they produce an output, hence they are code. They're often stored as pickle files or some other like insecure file formats. And now with the age of LLMs, that they can actually write code that runs, forget if it's correct or if it, if it logically does the right thing, but it does compile, it will run, and a lot of things can happen in that space that are very bad. The first point here I'm not really going to cover. This has to do with things like data poisoning. So now you have to kind of validate the data that you're putting into these models. But I am going to focus more on things that touch more of the infrastructure side. So how do you safely store your models? And how do you mitigate the risk of LLMs going crazy on your cloud infrastructure? But before I get into the details, I'm actually going to set up some basic attacks and a few ideas for mitigations. I think it's important to kind of level set on the machine learning lifecycle, which starts off with a problem definition. You have something you want to predict. You have some future data you want to predict, or some missing data you have at hand that you want to fill in the gaps of. So then you go in and some requirements are that you have the data set to solve this problem. So you go into the development phase of getting your data from the raw to the desired format. You train your model, and then if it passes a lot of the in-lab checks and metrics, performance metrics, then you put it into production. And there's a whole monitoring, debugging cycle. And then you kind of go back and kind of rinse and repeat, because these kinds of systems degrade over time without retraining. When I refer to orchestration, I refer to the coordination of the logical flow of the computations needed to get data from its raw state, in this case the data set, into some desired state. So that would be the trained model in production. Flyte is, as I mentioned earlier, it's an open source project. It is an orchestrator in the space of the ecosystem of orchestrators. And it is a scalable and flexible platform that will actually unify your data sources, where you can train your models and generate reports and understand and debug what's going on if something does go wrong. So training a model on Flyte looks a little bit like this. Each of these lines here are steps, right? So you have a step that loads the data. You have a step that splits the data into training and test set. You have one that trains the model, and then you have the last one that evaluates the model. So in Flyte tasks, these steps in your overall pipeline, they are containerized by default. And they are strongly typed, such that if it takes in an input, takes in a data frame, and it produces another data frame, then at least you have some kind of type definition to be able to analyze and know what pieces you can put together and what not. And workflows are the way you can define this orchestration kind of layer, where you stitch together different separate tasks into a larger, more complex system. So in the end, I'm not going to show you a whole demo or UI, but in the end, you get some kind of graph representation of this code right here. Does also sorts of things. It does some compile time checks, and it has its own type engine. But on Flyte, as I mentioned earlier, each of these steps happens on its own container, and Flyte actually takes the opinion of using Kubernetes to orchestrate the containers and the compute for this. So you can think of Flyte as like an ML AI specialized layer on top of Kubernetes. So this becomes important later. But the other part of the architecture that is relevant here is how data is passed from one container to the other, right? Because on one hand, you could just do all of these steps on the same runtime, right? But what if one step takes 10 hours and needs a CPU, and another takes 3 hours and needs a GPU? You don't want to take 13 hours on that one single GPU. You want to be able to separate the different logical units of your application with different heterogeneous resource requirements. So that's kind of like the base layer of Flyte and its kind of strong opinions. This is also important because Flyte, with the type system, knows how to load data in from blob store. It's a data frame with a CSV file or a Parquet file or something. And it also knows how to serialize it as the output of a task. The part to really be concerned about in this pipeline in particular is after the model training step, when the model gets serialized into blob store. Because this is where, by default, most ML practitioners, you just want to get to the result. You want to deploy the thing, you want to show it to your friends and family and whatever, coworkers. This is where you might take a lot of shortcuts. So you'll use pickle files, and I'll tell you why this is bad. Couldn't help it. So just to be super specific, right? In this train model task, there's a line that says joblib.dump. You could use pickle.dump, but it effectively creates a serialized form of the model that you can then deserialize at a later point. You might have a batch prediction pipeline somewhere else that's kicked off on a schedule. But when you load the data, this actually is executing arbitrary code. So this is, the biggest kind of attack vector for a lot of platforms, including Hugging Face, which is, they've spent a lot of time investing in security here, and they're still susceptible. So real quick, the anatomy of the 3 steps to model pickle attack. Step 1 is you create some kind of malicious code. In this case, obviously, I wouldn't call it pickle attack. I'd call it maybe something else in case you're doing some code scanning beforehand. But this reduce method here will execute at both serialization and deserialization. So when you deserialize the model, you can make all sorts of fun system calls here. Step 2 is I'm assuming you've somehow gained access to an object store. So this is where the organization stores all of its data lake, basically. This is a MinIO UI, but this could be S3, this could be GCS. But basically, you overwrite the pickle file with the corrupted file, and now when I execute that batch prediction step, I can prove to you in the logs that it's actually executed the code that I wrote. That's that would be worse if I had worse intentions. So Flyte buys you a few things for free. It's not. Yeah, sure, yeah. If you can remember the question, but go ahead.
So on that previous slide where you're showing that the attacker replaced the pickle file, is there not like any signature verification to know that file was changed?
Sure, yeah. So I'll show you what that looks like. But yeah, there's a way to do it at the user code level. But if you're an infra person, there's a way to bake it in more into the actual infrastructure. But yes, that is a great question. So a few of the things that Flyte gives you for free is the containerization. So this allows you to at least isolate, say this Flyte works with AWS and GCP and Azure. So whatever cloud provider you're using, whatever abstractions they have for container runtimes that are available to you that you can enable, the containerization of each step isolates at least the impact of any given attack. By default, containers do not run on root user and has limited access, and also has isolated configurable permissions either no IAM role to execute anything outside of the, has permission to access any other resource in the cloud. And this is also something that's configurable. The auto serialization, deserialization discourages pickling. So Flyte will do its best with certain types to store it either as protobuf or more secure formats like Parquet for big data files. But still, a lot of models, there's a safe tensors library out there for storing deep learning models. There are a few other libraries out there for things like scikit-learn models to store those securely. But again, these are kind of proactive. And by default, the blob store is configured to be immutable. So you can't overwrite certain files. So this attack that I showed you earlier is kind of less likely, unless you, again, somehow get admin permissions to the blob store. So as the gentleman there asked before, this is sort of, I'm just showing you in code. This is not how I'd actually do it in production, but you could extend the type system that Flyte already uses, which is just data classes with Python. So you could have the Flyte file here, which contains the pickle file, but you can also have a model hash that's computed when the model artifact is produced. And then whenever you use the model type, which is defined up here, anywhere in your code base, there is a validation check to make sure that the file hash matches the actual contents. So you can check for integrity there. So these are, I'm not a security expert actually, so a lot of you probably know a lot more about these topics. I came at this more from an ML person who likes correctness and validation and validity of things, so that's how I kind of got my feet wet in this area. But yeah, these are all kind of tried and true methods. So how you would use this type is, you would have a kind of a model guard task. A lot of people call these guardrails these days. And you invoke the model guard before passing it into any other task that consumes that model. And then this just shows you in the UI on Flyte, like here, there's a validation error here. The MD5 hashes don't match. So that's just one concrete mitigation. A few more ideas here would be to use more secure model serialization formats. So Onyx is one example. There's an skops library that gives the user a little bit more control over what can and can't be deserialized and things like this. And the safe tensors library for storing tensors, vectors for deep learning. Another idea is to use container runtimes and technologies like gvisor. So these will virtualize system calls. So this will just reduce the risk of, even if an attacker gets some kind of arbitrary code execution access into your server or your infrastructure, that system calls are virtualized, so you can essentially become no-ops. So that's kind of like on the classical ML side of any kind of model that you might train and use in production. These are, the pickle file is one thing to look out for. But there are some security issues introduced by LLMs, as I alluded to in the beginning of this talk. So agents, if you've seen this term around AI agents, there's a lot of ways to slice that cake, but basically in this context, agents are LLMs that are equipped with tools and control flow. So this is just a very simple schematic of implementation of one. So the user asks what's 2 + 2. For any, obviously the LLM might know in its weights the answer in output 4, but for say like what is the 99th digit of pi, you might want to use some kind of programming language to get pi and get the 99th index, et cetera, et cetera. So in these kinds of cases, you would want the agent to write some code or maybe a function call in JSON form. But in this extreme case, it literally outputs a string that a Python interpreter will then execute. You can see where I'm going here. There's a type of attack called prompt injection attack. It's a lot more clever than this. You can't just straight up say, like, write this attack. So there, yeah, you can look this up, but it's super clever to like, have the model pretend it's an API, give me the recipe for, making a bomb or something. And if you frame it in certain, or like, my grandma wants this recipe, and I really need it, then it'll jailbreak, and it'll counteract a lot of the guardrails that the LLM provider has already set up. Right, but if you're building these things from scratch with raw LLMs, like these are things to look out for. And basically, you can have the LLM forget all of its previous context, ignore any of previous instructions, and then download some file, execute that file. Just to revisit this diagram, I do want to just hammer home the things that you do get for free in Flyte, which is everything is containerized. So even the case that your machine gets compromised, you can at least circumscribe the impact and understand where exactly it started from. So I'll show you one mitigation around guardrails, but to prove, to just kind of show you the basic anatomy of that schematic I showed you. You get some kind of user prompt in your function. You have some kind of system prompt that says, hey, you're a helpful assistant. You generate Python code to answer questions and add some more constraints. The model will generate some code that you then parse. So it might output some markdown that you get the Python code fence and clean it up a little bit. And then you call the Python tool to execute the code. One proactive mitigation that you can do on Flyte and any other orchestrator, really, if you're careful, is you pull out the Python. So if you notice, the Python tool was invoked inside the same container that this LLM was contained in. Obviously, I'm using OpenAI, which is GPT-4o. But if you're self-hosting a model, if you have your own GPU here, and you have this risk of arbitrary code being executed in this piece of infrastructure, that's something GPUs are, where crypto miners are very happy, to have free GPUs. So you can pull it out into its own container, and the beauty of this is this can just use CPUs, right? Unless you're doing some crazy computation on Python, you're just running some simple code to evaluate some fairly lightweight computation. Then you compose it into a workflow, and you can just string these two. You generate the code, that's containerized and safe, and then you pass that string into the Python tool. Another proactive mitigation, this is also, I think, pretty common practice, but from an ML practitioner's perspective, this is the last thing you're thinking about. You're like, guardrails are something I would add maybe reactively if there's some system got compromised. But you have some forbidden patterns. You raise an error if they show up in the code string that's going to be executed. And then you add a decorator to the input-output boundary of the task that's generating the code. This is a lot of code, but really the important thing is this line, where you basically take the prompt and you have traditional code scanners. In this case, I'm using Bandit to just check for known vulnerabilities and insecure type patterns in Python. Then you raise an error. A fancier pattern here, I think there's a talk tomorrow by LLM Guard. I forget the company, but they're LLM-based ones, right? So Llama Guard 3, which Meta put out, I believe is a model that takes in some string, some output from an LLM, and it'll actually analyze it and output predictions of whether it's has toxic language. It has like 10 or so categories, one of which is insecure code. And similarly, you would add guardrails at the execution call site of the Python interpreter. The last thing I'll mention here is human-in-the-loop confirmation. So this is almost always a good idea if you can afford it. But instead of directly passing the generated code to the Python tool, you have an approval step where a human, writes some code to add a approval step, and then a human has to go in and either approve or reject the generated code that's shown over here. So some proactive mitigations on this attack, the prompt injection attack, is to use, again, gvisor here or some kind of container runtime that virtualizes system calls. This is always a good idea. Another idea is to always only give the agent access to trusted functions. If you need ultimate flexibility, then you're going to have it generate code and execute that. But for many use cases, at least that I've seen in industry and enterprises that are building seriously with this, they typically want more control and have a ton of guardrails around any of these kind of vulnerable sites. And yeah, in conclusion, just want to reiterate, models are code. They are stored as code, and they produce code. So we need to be careful about running that code that they produce. The two main things that Flyte provides, and this can be implemented, I'm sure, with a bunch of other orchestrators. You can implement this from scratch if you have the resources, but it's great to have node-level isolation when you're composing these complex kind of pipelines, and type safety, and a lot of the benefits you get out of that gives you the kind of building blocks to protect against a lot of these model-centric attacks. And with that, just some resources, the Flyte website, the repo that I based a lot of this talk on is available here. It's open source. You can actually run a little sandbox on your computer that runs a little Flyte cluster in there, so you can check it out and test it out for yourself. Thank you.